Okay, so factoring and solving polynomials. We're going to mostly factor today, and then next time we're together, we'll do more solving, right? But mostly talking about factoring today. So let me tell you what I mean. Yesterday we were factoring quadratics. The only thing we've factored up to this point is quadratics, really. So now we're going to talk about factoring polynomials, which could be bigger than just quadratic. Okay. So those skills that we have with factoring are still going to be involved, but there's going to be some more stuff going on. So factored form of a polynomial. You start with a big polynomial. You're trying to factor it. We've talked about this a little bit. Factored form is written as a product, meaning multiplying, product of multiple, not multiple scoliosis, but multiple polynomials, which is better than multiple. It's also multiple sclerosis, I think, not scoliosis. What? Yeah, I don't really know. I'm not a doctor. So you're taking a big polynomial, you're breaking it up into multiple polynomials that are being multiplied together, just breaking it up into pieces. What's the first step in factoring? First thing you always want to look for? Yes, all the time. Look for a GCF. First thing, that's going to make life a lot easier, especially today. Look for a GCF. Okay? Look for it. It's down there. Look for the GCF. You like that? That's clever. I've never done that before. Look for a GCF. All right, let's do one. Yep. Well, I mean, I have to. All right. So it tells me to factor this thing, x cubed minus 4x squared minus 5x. Now, you might dive right in and say, oh, let's do a times c, add to b, our big thing. But that only works if something is quadratic. Is that quadratic? No. What degree is that thing? Cubic, right? Third degree. Degree 3. So it's not a quadratic. I can't do a times c. But that does not mean that I can't factor it. I just have to do some other stuff. So first thing you want to look for all the time is look for a GCF. Is there a GCF? Okay. So let's take out x. It's going to be x squared minus 4x minus 5. So I'm just dividing each of those things by x. Now I'm left with that. Okay. Well, now that we have taken out the GCF, we want to ask ourselves the question, now that you have a factor that is what? You just said it. What is this thing now? It's quadratic. And we know how to factor that. You want to ask yourself, can that thing factor anymore? So it's like I'm ignoring the thing in front. I'm ignoring the x. I'm just looking at what's inside of here. It's quadratic. I'm asking myself, can that thing factor? Okay, so let's write it. X squared minus 4x minus 5. What's a? 1, so a times c is negative 5. You need two numbers. Yeah, two numbers that multiply to negative 5, add to negative 4. Negative 5 and 1. And since a is 1, what can you do? Since a is 1, you don't need to do all the grouping stuff. You can skip all those steps and just put your factors together. X minus 5, x plus 1. Okay? So far, so good? So the factored form of this thing that we started with is this. Yeah, exactly. This is not the factored form of this. This is the factored form of this quadratic that we had inside the parentheses, right? So in order to have the factored form of this is part of it, but what is this missing? The x that we took out at the very beginning. So the final factored form is x, the thing I took out at the beginning, times this. The x? You mean like if you wrote it like that? You're talking about, yeah, you're talking about these. Well, since multiplication is what we call associative, it doesn't matter. It's the associative property of multiplication. Multiplying this by this is the same thing as multiplying x by that and then that by that. Yeah. You can flip the order around in multiplication. It's okay. All right. So this is our final factored form. Does that make a little bit of sense? Okay. So again, we had to take a GCF out first. We had to look, oh boy. We took a GCF out first. We had to look at what was left over inside of there, try to factor that some more. This turned it to this. So then we put the x in front of that and we're done. All right. So why don't you try this one on your own? Okay. So first, so take out a GCF. What GCF can you take out? All right, so 3 goes, oh gosh. 3 goes into both of those numbers. And y, you could take a y cubed out of those. So take out 3y cubed. So what's left over? So I divided it all by 3y cubed, got y squared minus 16. So then I ignore the thing I just took out, 3y cubed. I look at what's inside the parentheses, y squared minus 16. I ask myself, can that factor more? What is that? It's a difference of squares. How do you know it's a difference of squares? Because I told you. It's because it's a quadratic, and it's missing b, right? It's missing the middle term. So when you have one like that, you always want to ask yourself, is it a difference of squares? If this is a perfect square, then yeah, it's a difference of squares, okay? So I look at both things. What's the leading coefficient of this? 1. So I ask myself, what's the square root of 1? Well, it's 1. And what's the square root of 16? 4. And then remember, the pattern is ax plus b times ax minus b, which means that thing factors to become x plus 4, x minus 4. Y, I mean y. Did you make a joke? Oh. All right, so we factored it down here, y plus 4, y minus 4. So what's the factored form? Say it.
3y cubic, y plus 4, and y minus 4.
Your final factored form must include every factor that you've come up with. It has to have, by factor, guys, I just mean like a piece. It must include every piece, not just the pieces of the thing that was in the parentheses, but it has to include the GCF that you took out. Every piece of the puzzle, you got to put it together in the end. Okay? All right. Okay, your turn for a little while. I'm not going to talk to you for a minute. How many of them are there? 1, 2, 3, 4, 5, 6, 7, 8. I don't know. You think you could do 4? I bet you could do 4.
I hope I can, otherwise I'll be pretty embarrassed.
Try to do 4. Bounce around. You don't have to do the first 4. If you get stuck on one, go to a different one. And what's the first thing you always do? GCF. All right, so last thing I need to show you. Sometimes you're going to be given a problem where you have a factor and you're asked to factor the rest of this thing. So I'll walk you through how to do it. What this says, it says if I know that 3 is a factor of 24, I know that 3 is a factor of 24. How do you find the matching factor? Math. 3 and what? To get 24. 8. How do you know? Because 24 divided by 3 is 8. So you can do division to find the remaining factor, because 24 divided by 3 is 8. That's how you know it's a factor, right? Because it divides. We talked about that 2 days ago. So in the same way, if you're given a polynomial and you're told to factor it, and you are told that you have one of the factors, you can get that process started by using division. You could divide this thing by this thing, and that's going to get you another factor, right? And then you can try to factor that thing. So you can get started by using division. So let me...
I'm not gonna lie, I don't think.
That's okay. Let's do an example. Let's do an example. Okay? So it says, given that x plus 3 is a factor of this thing, right? This thing, the big polynomial, in completely factored form. So I'm told to factor this thing. Well, let me ask you this. Is there a GCF in this? No. It's also 4 terms, so you can't, it's not a quadratic. So you can't do the a times c thing. So we don't really have any options, right? We can't take out a GCF. We can't do a times c add to b. But what can we do? Well, we're given a factor. And think back to when we were doing synthetic division. If this is a factor, what does it mean? Like, if I divide it, what's going to happen? I'm not going to have a remainder, right? It's going to divide evenly. So we're going to start by dividing this by this. Okay? I need to give myself more room on this. We'll do it over here. I'm going to divide this by this. Y'all remember how to do synthetic division from a couple days ago? Take the thing that you're dividing by, and what do I do with it?
You put in the
I got to flip it. I need the 0, right? So it's -3. And then I get the coefficients. Am I missing any terms? Nope. So I got 4, 9, -19, -30. Drop the first number down, and then we're doing multiply, add, multiply, add. -3 times 4 is -12. Add, what's that? -3. This times this is +9. Add, that's -10. This times this is +30. Add, and I get 0. Which should happen, right? Because I'm told that it is a factor. So if you're told that it is a factor and you divide and you get a remainder, that means you screwed something up. Because if it's a factor, it should divide evenly, right? You remember how to write the quotient? 4x squared minus 3x minus 10. Because remember, it's got to get bumped down 1 degree. So it was a 3rd degree. It gets bumped down to a quadratic now. Okay. So here's what we did. We took this big ugly thing. We divided it by this. And I got this. That means that if I did this times this, I would get back to the big ugly thing, right? Does this make sense? So you can rewrite this thing as this times this. Yep, so again, we're trying to factor, we're trying to split it up. Well, I have two factors here now. The division helped me get there. Okay. So now I'm just, again, I'm going to do what we were doing before. Oh, ho, ho. You don't like the color? So I took out this factor. Now I'm looking at this, and I'm asking myself, can I factor that thing more? Well, I don't know if I have room. Well, let's try it. 4x squared minus 3x minus 10. Is there a GCF there? Nope. A times c is negative 40. I need two things that multiply to negative 40 and add to negative 3. 8 and 5? Negative 8, positive 5? Negative 8, positive 5. Since the leading coefficient is not 1, we have to do the extra stuff, right? So I got to do 4x squared minus 8x plus 5x minus 10. Yeah, and then I do my grouping. Group it up. What can you take out of the first half? So that turns it into 2x minus 4. And what can you take out of the, or sorry, 2x minus 2, rather.
No, it's x.
Oh, yeah, sorry. Take out 4x, x minus 2. There we go. And what can you take out of the first, or the second piece? Negative.
No, positive 5.
Positive 5. And that would turn it into x minus 2, which is great because they match. So that means this factors to become x minus 2 times 4x plus 5. You guys tracking with me? So far, so good? All right. So now we got to put it all together, but we need to include the given factor, right? Because this thing is not the factored form of the polynomial that we started with, right? This is just the factored form of what was left over. So what is the final factored form? X plus 3, because I'm told that thing is a factor, so that should probably show up in my factored form, right? And then I got my other factors that I came up with. X minus 2 and 4x plus 5. Remember, you need every piece of the puzzle put together in the end. You need each factor all put together. Does that make a teeny bit of sense? So if you're given a factor at the beginning, you start by dividing. Whatever's left over, you try to factor that thing some more, and then you put all the pieces together in the end. All right. What? Oh, okay. I'll have you guys do one on your own in like 5 seconds. Actually, before I have you do one on your own, I'm going to show you one more quick thing. Is that okay? It's not going to take you very long. One more fast thing. Another pattern that you're going to see. We're not really going to do this a ton in this class. You might see it again come up, but it will definitely come up if you take like college algebra or pre-calc or something. It'll for sure come up in those classes. So I'm just going to show it to you here so that you don't go to those classes and be like, oh my gosh, I've never seen this before. Okay. So if you remember when we have a difference of squares, like we talked about, the ones with the square roots, the pattern of factoring that you come up with is ax plus b, ax minus b. There's also sum and difference of cubes, not squares. So things with a cube root. So if you have two things with a cube root, adding or subtracting, there's a certain pattern we can do. I'm going to show them to you right here. Like I said, they're not going to be crazy important for us. I just want you to see them one time before you go to a college algebra or pre-calculus. Okay. Here it is. You ready? See if I can remember this. If it's the sum, well, you got to find the cube root of these things. And then it's a plus b a squared minus ab plus b squared. Plus minus plus. Yeah, I think that's it. And then minus is a kind of similar. It's a minus b a squared plus ab plus b squared. So if it's a sum of cubes, it goes plus minus plus. If it's a difference of cubes, it goes minus plus plus. So again, this is just a pattern that you can use, and you will see that later on in college algebra or pre-calc, but we won't do it a ton in this class. I just want to show it to you. All right? Fair enough? I'll do one quick example of that, and then I'll turn you loose. So like, let's say, oh boy. Let's say I have, let's do this one. It is a difference, and I'm looking for cubes now. So not square roots, but cube roots. What's the cube root of 8? Something that if you multiply it by itself 3 times, you get 8. 2. And what's the cube root of 125? 5. Okay, so A is 2, B is 5. It's a difference of cubes, so the pattern is A, you need an X in there too. Oh yeah, sorry, so X cubed, the cube root of X cubed is X, right? So A is 2X, B is 5. So it's a difference, so it's A minus B, A squared plus AB minus B, or sorry, plus B squared. That's the pattern for a difference. So you just take A and B and you put them in there. So it would be 2x minus 5, 2x squared plus 2x times 5 plus 5 squared. And we can simplify that a little bit. I have 2x minus 5. 2x squared is 4x squared. 2x times 5 is plus 10x. And 5 squared is plus 25. Those are the cube roots of the pieces that I started with. So that's how you put it all together, but remember, like I said, this is not going to be crazy important in this class, but if you find yourself in college algebra or a pre-calc, you will do this, okay? Yeah. Yeah, this is it right here. Okay? So like I said, I just want to show it to you. I want you to see it, know that it exists, so that you're not going into college algebra blind. Mm-hmm. Yep. Yeah, you should.